This is video 5 for chapter 10, part 2 on muscle physiology. So we just finished talking about the different types of muscle contraction. And if we look at length versus tension, the number of cross bridges formed. During contraction. And remember that these are being constantly formed and being released and then being reformed, being released until the muscle contracts. The number of those formed determines the force of contraction. So how far the muscle shortens, which gives us how much tension can be produced. So the length of a muscle helps in the number of cross bridges formed. What this amounts to is the optimal length gives optimal force. So those of you that might swim, or those of you that might run track, those of you that play basketball, or any kind of sport, there is usually a starting position that you are in. So if you are swimming, you are on the block and you are in a certain stance. You are stretching some of your muscles in a certain manner. If you're on track, you are on the blocks, especially if you are doing a short distance. That gives you a competitive advantage in that stance. In football, everybody starts at a stance, but you are already in a contracted state. So your muscles are at a certain length that is going to promote having an optimal force generated. So you are basically priming your muscle. So you have gone through trepa, you have the maximum amount of contraction possible, you've warmed up your muscles. So now you are giving your muscles a chance to have the maximum number of cross bridges formed to give an optimal force. So those stances that you're in give you an advantage. So if you are participating in maybe the 50-yard dash or 100-yard dash, whatever you're doing in track, your muscles are already in that certain position, which is very helpful. Now, as you are contracting and contracting and contracting muscles, you can experience what is called fatigue. Fatigue is a decreased capacity to do work. And this relates to muscle contraction. We have all experienced fatigue. If you're a long distance person, either swimming or track, cross country, you know that after you go a certain amount, you start fading. Soccer, towards the last part of the game, you might be experiencing a decreased capacity to do work. Now, you do practice and you maintain a certain level, but you start feeling it after a while. The more you exercise your body and practice, you can start decreasing the effects of fatigue and you can last longer. That's why you practice. But there are different types of fatigue. The first one is psychologic. This involves the central nervous system. So in this one, the muscles are capable of normal functioning. But your brain is causing you to have this feeling or causing the muscles to no longer be able to contract. Sometimes it might be a paralyzing fear of something that causes you just to freeze. That is your brain overriding your voluntary system. So, if you come across something and it's just shocking and you're just standing there and like, I can't move a muscle, that is psychologic fatigue. You cannot contract your muscles because your brain is basically stunning you. This can be paralyzing. But your muscles are perfectly normal. There's nothing wrong with them. Muscular fatigue is just the reduced ability of contraction. So this could be from exercising a long period of time. You've done way too many reps of a certain exercise. Your muscles are tired. You're tired. You can't go on anymore. So you start to slow down. You try to combat this by slowly increasing the number of reps if you're exercising. Maybe instead of running, 10 minutes on the treadmill, you start a little bit lower and you build yourself up to help reduce muscular fatigue. So you start at a lower pace, you start at a lower time, and then you can gradually build that up. It would be really silly for somebody to go out and say, I'm going to run a marathon today, and you haven't run more than 10 feet the past 10 years, and you all of a sudden decide you're going to run a marathon. Maybe somebody trains for a year and they build up to those a little bit over 26 miles of running. Otherwise, you're just going to basically fall over at some point. The last type is called physiologic contracture. This is an extreme form of muscular fatigue. Here, the muscles are incapable of relaxing or further contraction. Basically, what you have done if you reach this state is you have depleted ATP stores and a lot of your energy stores like your glucose, your glycogen, you have started to deplete those. You are going to be using lactic acid and you're going to have that build up in your body and it's going to hurt and you just fall over. You could experience muscles incapable of relaxing, so you end up with a lot of cramps, or if those muscles are relaxed, they just don't work anymore. So this is a pretty dangerous state. You do not want to go into this. So if you deplete the ATP stores, the cross bridges do not release. Because remember that when ATP binds to the myosin head, it releases that cross bridge. Well, guess what? If we don't have any ATP, it's going to remain there and you cannot relax those muscles. It doesn't let go. This also happens in death. So rigor mortis basically means stiff death. Rigor means stiff, mortis, death. This is something that occurs several hours after death, but it is dependent on environmental conditions. Usually the warmer it is, the faster that this sets in. And when someone dies, basically your ATP stores are gone. So you're no longer making ATP, and the calcium plus 2 pumps in the SR fail. Now, the calcium remains in the sarcoplasm. No ATP means that we end up with the muscles all contracting in the body. So whatever position the body is in, it remains in that position when rigor mortis sets in. So if somebody were to die sitting in their recliner, several hours after death, if they discover the body and they try to move it, the body is going to be in that position. You cannot change the body. This is going to last until our favorite organelle, lysosomes, our suicide sacs, start breaking open and begin to digest muscle. So we begin to decompose. That's where the environmental conditions come in. These lysosomes and the enzymes that are inside do better at warm temperatures. When a body dies, it starts cooling down a little bit if it is in a cooler environment. So it takes a little bit longer for these enzymes to work, and the body is preserved in that position for a little bit longer. If it's very warm outside, warmer than body temperature, then these lysosomes are going to break open sooner. So it starts decomposing quickly, and rigor mortis doesn't set in. Somebody that looks at death is going to, like a coroner, is going to look at the environmental conditions and the state of the body to give an approximate time of death for somebody that has died, or where there are no witnesses as of time of death.